So then you get, of course, other components. So other component, and this component can talk to this component. So let's say, I don't know, speakers have sessions, or sessions have speakers, something like this. And still no microservices. So what you will end up having are packages in Java. So this is a Java folder, Java package, and Java package in a layer, and I call the layer business. What I forgot to mention, why I use this boundary control entity naming is very simple. If you are in boring enterprise projects, you have to argue about stuff which actually does not matter. This is a Parkinson law of triviality. The more trivial the decision is, the more expensive it is to make. So it is like a psychological problem. And with my inventions, I always had to argue, why I name it service and not facade, and why it's not activity and not service. But if I find something which is standardized, there is no discussion. So look, I think it was Ivar Jacobson back then. He invented a boundary control entity. Just take this, and with these icons, we can use whatever tool we like. There is even stuff for, how it's called, OmniGraffle and Visio and UML. It doesn't have to be UML. All tools I know have support for these icons. So this is actually why I use the naming. I don't like the name control, but who cares about this? If the semantics are clear, is okay. And entity is not out. Boundary is okay. I would say something like service would be better, and E for or domain would be even better. But if I would start with what was BSD, no one knew what it actually is. So, and the question is, how many components? So then, what is this package here? So, what this is the layer, and I call it the layer business. So, what it means in Java, we would have something like pl.devox.business. This is the layer, and in this business layer, we get the components, packages with the name attendees, speakers, sessions, or whatever. Can you see it? Okay. So, the question now is how the components talk to each other. And what we did so far, there was no interfaces, no dedicated, contracts, because I think it is not worth of doing this. In Java EE, what will happen if this boundary would like to talk to this control? We can simply inject this control. If the boundary is not happy with this control, we can replace the control without any friction, just using specializers or something. So there are lots of mechanisms in Java EE to swap things without factories and strange patterns. So actually factories, there are no more factories and no more singleton. In Java, everything should be deleted like this. So if you see something with the name factory, the chances are high you can delete it without any trouble. Questions so far? Everyone agreed? So first, it disturbs the architects that I allow, that one component talks without any restriction to the other component. And someone said, I think it was even 33rd degree or something like this, what you are talking about is monolithic architecture. And my answer was, you are actually absolutely right. What I would like to do is very pragmatic monolith. So this is a monolith because you will never be able to take, for instance, the speakers component and extract it and put it somewhere else. My point is, I cannot imagine such requirement. So I think I started with Java and JDK 1.0, so now I think I know it. And I never saw that actually, and whatever modularization we used, that one component can be just extracted out of the box from the application and run somewhere else. This was, the dreams of Genie, RMI, Corba, or whatever, but it actually, what should such a requirement be? And if such a requirement comes, the question is, how expensive would it be, to extract this to somewhere else? So how many days I would spend to use this component and put the component somewhere else? Okay? So if there is no requirements, there are no additional patterns in my project. It's just that simple business code. And in my eyes, architecture is about probability. So if something is not likely, I don't consider it. So I say, okay, forget it. So it could be that one day the venue will run on a different server if we scale, if a DevOps will be something like, I don't know, we get here 50K developers. But then probably we'll have enough budget to replace the component with something else. So this is actually my thinking. It is, I think, more better than over-engineered the application from the beginning. Everyone still agreed? So what we get is One business layer with, I would say, 5 to 10 components. If you think about this, a component will have probably 5 to 10 entities, so we end up having, 100 tables. So it's actually database tables. It's actually a reasonable system. And the tables usually is not one-to-one relations. You will do, translation tables, whatever. It could end up with several hundred tables with 10 components. So, and now the question is how to deploy the thing. And what we did in Java EE, we used this and we deployed this with a WAR, Web Archive. So EARs are actually no more fashionable for several years, I would say five years at least. Why fashionable? This was a solution for non-existing problems in most projects, because in EARs you can deploy multiple EGB jars and WARs, but why you have multiple EGB jars in a WAR? The hope was that you could replace one EGB jar without affecting the others, but if you deploy everything at once, no one cares. Whether I deployed the whole EAR or the EAR with one EGB jar or 5 EGB jars, no one actually cares. So at the time, if I used EARs, I always had a huge EGB jar inside in one WAR, so we were forced to use EARs, but at least it was faster than having 50 EGB jars. So the default architecture was one WAR, no EGB jars, no jars inside. That simple design. What's important for me is the packaging in Java. Naming, packaging, simplicity in Java code, not deployment. Deployment does not matter. So what it actually means, we have WARs. So we have one WAR, and this WAR could be created by a team. So what I think is a common sense, team should be as small as possible. So I would say team between 2 and 5 developers could manage to implement whatever they like if they are passionate and motivated. The larger the team, the harder it is to keep the passion and motivation. This is like it is. So I think Yahoo or someone said one pizza team. So teams should survive from one pizza. No kidding. So there was, but they mentioned family pizza. I would say family pizza is already too large. So really 2 to 3, 5 is already too much. Developers can build such a thing. So now the question is, what happens if we have moving parts? Let's say the venue always remains the same, but the speaker component always changes the whole time. I don't know. The speakers have, I don't know, social, what can have social and social interactions, and we can have DNA scans and I don't know, several things which always changes. And now what we can do is we can say, okay, we dedicate another team for the speakers, and what even more importantly, what could happen that the components, the speaker component has completely different life cycle from the venue. Okay, this is actually a valid case. Actually right now in my projects, it is actually over, but it was a project, was a banking application in Java 7, and this was from the beginning clear that each team has completely different life cycle. So if each team has completely different life cycle and all teams have to work together, it is actually a very bad idea to deploy one WAR. Because whatever happens, we have to redeploy, and we could affect other teams. I hope it's reasonable. Okay? Still with me? Could you find something not reasonable in the talk so far? I would like to give you a t-shirt still. No, everyone reasonable. There's a strange audience here in Poland. Always everyone says yes, right? What it means, starting with in boring enterprise project, you have 2 teams, and one team would has their different budgets, and one team would like to deploy Mondays and the other one Sundays. What happens then? I think the reasonable part is to introduce 2 WARs. So what happens then? We create another WAR with another component, and because we are not very, I would say, it is not the world is not perfect. So what it means it will never happen that the components are completely independent of each other. So this component will have relations to each other. And the question is how to implement the relations. So we have 2 WARs now. So we will have 2 WARs. What we said, speakers is one WAR, and venue is another WAR. This is very stable because this won't change, but the speakers change all the time, the different requirements or whatever. And the speakers would like, or not would like, will know from the venue the coordinates or speaker rooms or whatever. So how to implement this? And so far, what I told you is I consider this building a monolith. So one WAR without any jar partitioning within the war is for me good practice, and the reasoning is simple. And it builds faster. No jars, no zipping, builds faster. And fast deploy is very, very important for productivity. So now we have the problem. We have to communicate. There's one JVM, could be on Docker or not. It actually absolutely does not matter. So in the last workshop, we deployed everything on Docker, but I mean, you could run on Docker or not. Docker makes it a little bit more convenient, but it's actually no difference for the architecture. So the speakers communicate to venue, and now the point is we have two monoliths without any contracts, nothing. But now I would not allow any shared classes. Because there are two different life cycles, I think it is a very bad idea. What many microservice project attempt is to say, okay, the venue has some DTOs, and I would like to share the DTOs. So if you share the DTOs, you have binary coupling between wars, and we are at the beginning. So if you would really like to have the independent lifecycle, I think the only thing you can do is to have REST with JSON or XML. Actually, it does not matter. But this team is responsible to interpret the REST interface from this team and create the object however they like. Whether they use JSON objects or Xstream or JAXB, no one cares. They are in charge of maintaining the DTOs, even if the DTOs exist here. So the sad fact of microservices is duplication. In each good microservice architecture, you will find redundancies, because you will have to duplicate code, because if you share the code, it is not independent. Okay? Everyone agreed? And even microservices are dreaming that you could implement this in PHP and this in Java and something else in Scala or Clojure, then it's over for sure with code sharing. So this code sharing only works if we have a microservice written in Java, which talks to another microservice also written in Java. Still everyone agrees? So the first impact on microservices is redundancies are best practice. And this is nothing new, it's the same story for NoSQL. NoSQL databases are having redundant data in the structure is a best practice. This is complete opposite to relational database. Still everyone with me? So the first complexity is we have to introduce redundancy, so the other team has to implement objects which already exist in the other bucket just to be not dependent. Okay? And this is actually, we did it in projects without mentioning microservices. This is just like it is in distributed world. And this is what Corba tried to address, or SOAP tried to address with the WSDL and all the stuff to generate everything from the contract. But the question is, who is in charge of the contract? So if the WSDL is in the middle, you have the same problem. Okay? Any questions? No questions. Okay, so yes. If you louder, the 5 microservices I got, and then we have to louder or come here. Yeah. Yeah. Yes. Mm-hmm. Yes. Yeah, what you are saying is you have customer which is shared, and the customer is changes because, let's say the venue changes, and the speaker does not know about this, how to deal with this? Is this the question? Yes. Yes. The definition of a customer changes, whether this is WSDL, SOAP, or whatever, and the question is how to deal with that, right? Okay, first you get a T-shirt. So it's large, very good. And I can answer it right away to save time. So, and this is another observation. So let's say the question was we have venue, and the venue gets, I don't know, additional facilities, and the speaker does not know about this, and you share the DTO, which I actually didn't propagate it. So what I think in microservices is a bad idea to use type-safe interfaces. So if you introduce a type-safe contract, even minor change on the type-safe contract would break everything. So I think a way to survive this would be the following, that this department here uses the interface, writes unit tests, and tests again this one, and even it would be a great idea to contribute the unit tests to the CI here. So if something breaks for them, you will recognize on each commit, on every commit in the CI here, which also costs with additional costs. Remember, in a monolith, I could just call the method, period. What you are saying would be compiler error. Because we have two copies of the same idea on two microservices, we need a solution for this, and the solution for this is more testing. Which is okay, but I would say even in my monolith, they are not perfectly tested. Who is in a Java EE project which is well tested? Okay, so it won't get any better in microservices world. Okay, so this is the reality. So what it means, you have to dedicate more time to deal with the incompatibilities between services. How to deal with this as well? What we always did, we split the war in two parts. So war with business logic, and the other part was system test, what I called. So I had a REST client, JAX REST 2.0, for instance, and prior Java 7, we used Jersey plain to talk to the backend, to the REST. And if you use Maven, both projects are versioned. And in Jenkins, I think there is a plugin called Metrics Build or something. And what we attempted to do is to check out all existing versions of the system tests and run against the newest version of the business logic. So we get like regression tests for free. And this is the only thing it works in such an environment. Because if you share classes, I think then it's a pointless if you have 5 microservices on JVMs, you know. It doesn't make any sense anymore. You introduce complexity without any additional added value, and you could still break, even if you change the JVM version. So we had it already, from JDK 1.3, I think, to 1.4. The course came to exceptions, and it broke the whole binary communication between servers. Very good. Large, right? Okay, nice question. So I actually almost forgot what I wanted to say here. So we had the first thing was the complexity because of redundancy. The next thing is complexity because of testing and compatibility. And the third thing is the most important thing is, if you think what happens right now, we get a distributed system. So far on a monolith, run in a process. If you don't run in a process, there's a stretch theorem called CAP, consistency, availability, partition tolerance. I would argue this CAP is a little bit hard to understand. What it boils down to is distribution, scalability, consistency, and pick 2 out of 3. And what it actually means, if you split your monolith to multiple microservices, you get a distributed system, and ACID won't work anymore. So what is the solution? The solution of the problem is actually to try to think in business transactions as a larger concept, but first you have to understand the business a little bit more, and you have to compensate failures. Okay? So is it less complicated? No. It is far more complicated than a monolith. In a monolith, you get commit or rollback, nothing else. So if you actually, in Java 8, there is not even mention of a transaction. It is enough to invoke a method. And if you get runtime exception, the whole transaction is going to be rolled back. So in my eyes, ACID is best practice because it's simpler. But if you distribute the system, there is no more ACID. You should not even attempt to use XA because it doesn't work in distributed system well enough. And then we need a workaround. And the workaround is base. Basic availability, soft state, eventual consistency. So, and what it means, now we have to implement transactions and compensate transactions by our own and always ask the domain people whether it is the right solution or not. Everyone agreed? If it's too high level, I will try to find some examples for you. Everyone agreed still? No questions? Very good. Loud. Oh, very. Histories. Yes. Very good. So first, Hystrix is I would say, how it looks like. It is like, it's actually executor service. If search for Porcupine on my GitHub account is very similar with 5 classes in Java. But the problem is not the backup method. We could implement it straight away. So actually, yeah, next DevOps, we could do this. The problem is what to do in the backup method. Just think about this. We are modeling something like an Amazon, okay? And this is a monolith. So in a monolith, I could charge your card and send the package in one transaction. Agreed? So now let's say no. The mailing service and payment service are two microservices. Agreed? Yeah, but let's to make it obvious. So now, what I could say, I can charge a card with a backup method. So the backup would be uncharge the card. But how to send, the package? And this is two-phase commit problem. We get basically two-phase commit problem. So what we have to do is to model everything in an idempotent way, so we can charge multiple times without side effects. So this is what happens, we have to implement. And then, how to roll back a package which is sent. Okay? So actually, the problem is commit is a commit. You cannot roll back and commit. It's done. So what we need is compensative transactions, which makes stuff more complex. So the solution to the problem is not say, I didn't send the package, it's over. The package is sent and is in a physical way. The postman is carrying the package to your home, so you cannot say, come back. It does work that way. So what we need, the backup method, the compensative transaction should be like a mailing the customer, please send them back, this package. This is what I mean. The technology is not a problem at all. If you look at Porcupine, there's everything solved. Even if you look at completable future from Java 8, exceptionally go to something else, there's everything solved without any additional library or stuff. So what I try to express here, the complexity comes from the business logic. Because commit, you cannot undo a commit, so we need a business transactions which makes sense. Agreed with me? So it's like, in Git, if you say commit, it's a commit. So you cannot say, I didn't commit this, and if you push it, it's over, completely over. So and now even if I will implement Git, with Hystrix, what will be the backup method of push? Now pull isn't, right? There's nothing. Like going to all developers, like please forget my last commit. I will try to reset it locally and override the global repository. This will be the backup method. So I think this is the next problem of microservices. We try to solve the problems with technology, which is impossible. I would argue whether you're using Spring Boot, Spring Data, Hystrix, Netflix, or Java EE, you will have to focus on the business logic first. And if you split your application with whatever framework you're using in multiple processes, you are already screwed, because then you have to think a lot about all the corner cases. Agreed? So. Yeah, this is an excellent point. So you get 2 T-shirts even. Yeah. And I was I think it was JDK.io in the beginning of the year conference. We talked a little bit of microservices, and Attendee told me, why are you not using PHP? It is a more microservice-like. It's like, who cares about your PHP? Yeah, whether you use a Java, PHP, Scala, or Clojure, it doesn't matter. So we have the same problems. And the point being, if we know the solution to the problem, how to unpush a commit on Git, then you can use Hystrix, whatever you like, or Visual Basic even, and it's going to be simple. Okay? So what I see, really, the first day on the project is which tool we should use. Hystrix or NoSQL. It's like, what would you like to build first? And then see whether your technology miracles will actually work, right? So what I'm going with this, very slowly, is if we get the third box, we get out-of-the-box microservice architecture in Java EE, and the driver was not that we would like to be more efficient or more productive. The driver was, very simply, we have different departments with different life cycles. If they communicate with each other, it's a good thing to be independent, and the only reasonable technology right now to do this is actually REST. So if you do this, we get microservice architecture out of the box. If you use Docker, it's a little bit easier because we can link the containers. Without Docker, it's a little bit harder, but you will get microservice architecture out of the box. Okay? And also here, Java EE is not microservice capable because this is too bloated or whatever. The times are over. Whatever application server you look at is about 100 megs of download size and about 10 to 30 megabyte of RAM overhead. So I had the slides over and over again. So if you search for my prior sessions, you will find these slides from with Java Visual VM. Oh, this is the first time happened ever that my notebook slept. Okay, so the point being, two-phase commit does not work, ACID would work, and now what's the point with microservices? So now the question, why Netflix, Twitter, Facebook, and the others are thinking about microservices? And if you search for the motivations, what you can do with microservices is the following. Because we have redundancies and independencies between wars, we can put more developers on the project and move faster, but the costs are substantially higher. So what can happen is that each box has some redundant stuff and is developed twice, but this is not a huge problem because we can put more resources on the project. So actually, the driving idea of the others is not lifecycle, what we had in enterprise, what Netflix, time to market. The faster they go, the better it is. And if it costs more, it costs more. They have almost unlimited budgets, so the budget not a problem. But if I go to my enterprise and we say, oh, we can put 30% more developers on the project, but it will cost 50% more, no one agrees with that in my world. Okay? I'm not at Netflix and also not at Twitter. So I think you should be careful in which context you are working. Are you are you a startup where you have to move crazy fast to be the first on the market, and you have unlimited budget or resources, many developers who work 24/7, then you could go with microservices. This is a business case, but it will never be cheaper or simpler. Everyone agreed? So, and with the distribution, consistency and scalability, this is the next problem. Most of the startups I know, they don't care about consistency because from day one, they could develop or think about the business logic that way that the consistency does not actually matter. If you fly with the airline and you have a ticket, what can happen? The flight is overbooked, and you will be going to be asked, would you like to sleep here or get another plane? This will be the backup methods, for instance, in the airplane. The same in the hotel. If it's overbooked and you have a status, chief platinum, whatever, then you still get a room. It's also a backup method. So there's also from day one, there is some business cases that they thought about this. So in the enterprise, the problem is in my projects was that everything was consistent so far. So even worse, everything run on the mainframe in one transaction. Crazy fast, crazy consistent because everything was in one process. In the older mainframes, even the database was in memory of the application. So everything was in memory. So and now we try to split one process in several processes, what microservices are about. So what it actually means, it cannot be consistent and scalable at the same time. Why not? Just think about a hash map which is distributed, something like Hazelcast, cache, or something like this. So if you have a hash map on 2 JVMs, you have to make the decision how the hash maps, distributed hash map, have to be replicated. Okay, very simple case. Consistency would mean synchronous. If I write something here, it should appear there, and then the transaction is successful. Okay, this is also what NoSQL databases are doing. You can set it up, configure this. Okay, so this will never scale because if you get 5 nodes and you write a lot, it will take longer than 2. So, but if you would like to scale, you can synchronize or replicate asynchronously. It cannot be consistent, but it scales. And this decision needs to be made for everything, for JPA caches, for Hibernate caches, if you have multiple nodes, and even for the data. So, and this is also additional costs if you distribute a system with microservices. Any questions? So, I think it's time for the next slide. So, Java architecture before microservices. I would say the Java architecture before microservices was one war. And sometimes the problem is we put too much in one more, and if the life cycle of different components of the war was different, we had to redeploy the war too often. This was the problem. With microservices, it is a valid idea to say, if we have two teams with complete different life cycles, it's a good idea to create two wars. But you shouldn't create 50 wars. This is my point. It's not like if you go back home and say, oh, microservices, we split our monolith to 20 microservices and we can redeploy everything, and everything is going to be simpler and even cheaper, and you will never sleep, I would say, if you do this. Okay? So we get two wars, and now it is perfectly fine to say, my war communicate with the other war just using REST. Back then, you will be asked by architect, do we JCA or JMS or whatever, you can still use it. It's just perfectly fine. Even WebSockets is fine. So we have in Java JMS WebSockets, but you could also use REST if done correctly. So what does correctly in REST mean? REST also means we should expose the business logic and not try to invoke methods. This is the common mistake I see in Java, or mistake. It leads that it is actually unusable. So if you look at the URI and you are the business experts, you should know what's going on in the system. This is a well-done REST service. And if you look at the PayPal REST API or GitHub REST API, on app.NET REST API, they're actually perfect. If you look just at the URI, you immediately know how to use this. So this is also my point. REST is always a good idea because the API self-documents itself. Questions so far? No questions, of course. So Java architecture before microservices was reasonable. What it actually meant is we got a view wars which communicated with each other, and these wars comprised an application. So, and this was the last. And after microservices, it is actually no different. So now we can put a label, microservices, on our system and say we are a microservice aware, and no kidding, this is exactly what happened. So in the banking, we had 8 different wars. And now I say, by the way, we are also microservice aware, and the architect said, okay, fine. So I don't care, but if it works, perfect. So this is the best possible case. So for me, microservices are not the best practice. Microservices are workaround. A microservice are a how to call it? It's a solution to or a solution. A workaround for a problem you get, and the problem is you cannot deploy a monolith anymore. And there can be different reasons. Either it's applications really too huge, and this usually means crazy architects. I know 5 gigs of dependencies without any reasons, but this is a different problem. Or really you are building something really huge. So to give you an example, in one project, I think there were 6 or 7 developers working for 6 years already. This is actually a large system, and we have exactly 1 war without anything. So it works fine. Okay, so there is no reason to create. It would never cheaper, better, or whatever to create from this war 5 wars, because their life cycle is always the same. There's one release, perfect. The one file is copied to production, always works, and it's always easier to copy 1 file than 5. Okay, you have to think about the deployment and so forth, the order of deployment. So, any questions? Everyone agreed? It's a very controversial topic. Even Hystrix or Spring. Everyone here? Yes. Using components in where? How many components are put in one war? Is this a question? Usually 5 to 10, I would say. No, really, I could also have 100 components in one war if there is no additional requirement. So what is the addition? What is the problem? When I would consider splitting, if deployment is too slow. So and the deployment is usually slow in case you have too much stuff which is going to be scanned, crazy architects, or name queries or something, which lots of prepared statements because it happens at deployment time. This is usually the reason, and this is technical reasons. And I would say Conway's law thing is you have different budgets in project or moving parts which move at different speed. You know, in our case, the venue remains the same for 2 years, but the speaker module changes all the time. Then I think it's a good idea to have two wars, venue and speakers. Okay? So my point being, if you have two wars and a new developer in the team, you should be able, with one sentence or two sentences, to explain him or her why we have two wars. And if the answer is, or the explanation is, we have two wars because of microservices, wrong one. Because of modularization is also wrong. So in the recent project reviewed, we had several hundreds POMs, Maven modules. There's nothing worse, just Maven modules. And asked the question why, there was no answer. And they complained about build performance. It's like, okay, but I mean, why are you doing this? Just create one. If there's no requirements, I had to open, I saw it was like, it was crazy. The workspace, it couldn't even open it with the IDEs. So, everything looked right because of micro modules. There was the question why, no one could answer why. So there's, huge effort and no reason for this cargo cult. So there should be no more cargo cult. So my best practice would be create as few as possible wars and create as nice as possible components. So components have to have domain meaning. So nice names, and classes have to be named correctly. And in Java E world, what I can say is no interfaces, no Gang of 4 patterns, everything is a part of the platform. So you get a clean code with a view annotations and always the same structure, and components are only allowed to have business names and not commons, util, platform, library, whatever. Whatever you find meaningless, you should consider splitting it or delete it. Very good. Scalability. Mm-hmm. A very good one. So I said one of the business cases of microservices are better for scalability. So in my world, it's not the case. So even the problem in my world, the bottleneck is always the database. So if you provide stress tests and load tests, even in a simple Java E cluster, it was really hard to utilize the server. So what was the server was almost idle, 30%, 40%, but there is not a lot of algorithms going on the server, and the database just logs everything. So two answers to this. First, microservices is true for scalability in case on your microservice do something algorithmic, like image processing, absolutely true. Then you can just start on-demand multiple instances so there is no shared data. And therefore, microservices have a pattern which is called, I think, data silo or something. So what it actually means, if you have a microservice, one war would get even redundant data. So one war talks to exactly one database. So this is a best practice. It is really hard to implement this in the enterprise, but this would be the official pattern from microservices. Try to deploy it in your company. It's the following. So I didn't even mention this because it's a little bit radical. So this is a microservice. And this is our war. And it would mean each war has a database, dedicated database, and this is not possible. So this war will have to talk to this war to access this database. So we get the data silos. So it means in the perfect microservice world, the data would be redundant as well, or you would use NoSQL database, or you will have to, again, implement your backup method. So it boils down to this. So if you have shared database, forget about this. And most enterprises have to have shared databases. It's really hard to say, by a bank, we have 3 databases, and they are not always consistent, but in one point of time they will be. So this is only doable if we implement more business logic at the front end. You got me? So if you have not I/O-bound microservices, like computations, perfect. SETI, search for extraterrestrial intelligence. SETI? This would be perfect case. You send a bunch of data and get the result. You can scale indefinitely. But if you have a common database, like let's say flight scheduling again. Flight scheduling database, it will start 50 flight schedulers. I don't think they will scale better than 1 or 2. Because everyone will hit to the database at the same time. Very good. Other questions? Yeah.
You mentioned some
About what? Entity? So the question is, how is the duplication of my project? First, hopefully, you see, I don't try to propagate microservices. So it's not like, so in the recent microservice-like project, the duplication was not very high because we use Java 7 and JSON object. If we use JSON object, the Sonar won't find this, right? So in the earlier times, what we had, the JAX-B, the objects were also different. They were in different packages. It was not always found by Sonar, but it is not a big deal. So it sounds dramatic, but in fact, first, REST is coarser grained than method call. So you would send like no order and send the whole order object. So it is really easy. It is not as labor intensive as creating finer grained parameters for each method call. So for Sonar, it was not a big deal. So, but there's always a lot of discussion if you try to do something like this in enterprise. And again, my motivation was not to have microservices. My motivation was to have independent teams. And then we always talk about shared classes, always. We would like to share classes and how to version the classes. And my question was always, if you have binary classes, forget about the microservices or whatever. Just put everything in one word, doesn't matter anymore. OK? Also a t-shirt. Come to me after the show, so you get one. Very good. Other questions? So we have still 8 minutes to go. Yes? So what I understood is you have a database with 10 tables and 5 microservices, and I would like to implement a report. So yeah, report is actually fine because you can create a report microservice which goes to the database directly. This would be perfect case, actually, because you would say, no, report changes frequently, and they just put in a war and forget the others. Because reports are reports, they always change, OK? So no questions. So I will show you an example, which I actually can show you just on the table, because source code you have no too much time for this. And this is actually my blog and how it became a microservice without wanting it. Because it's a very, very simple example, I would like to share it with you. So my blog is Roller Weblogger. It's a Java software. And I think 5-6 years ago, the problem was my Apache log files were too big and the night was too short to process them. And I thought, probably someone wanted to hack me. So which articles are so popular? And I wanted to see what's going on inside. So because it's Java software, my idea was to create a filter, servlet filter, and just see what happens behind the scenes. So I saw what happens, and I wanted to store it in a JPA database into query, which posts are popular and why. The problem was the Roller Weblogger contains Spring old version, and the Spring old version uses Hibernate, and it was impossible, for instance, on Glassfish to use Eclipse Link at the same time. It was strange errors, whatever. It's like, oh. Then I introduced another war, and this war is called X-Ray. This was the blue book. But the X-Ray, what happens, I just sent put requests. So the nice story is the lifecycle of the Roller Weblogger was completely independent of my software. So the only interface was put, the URI, which the user read, and the header, period, nothing else. So and this, I provided the statistics. So in my blog, you will see a small number, which article was read how many times. The problem is, I got many ideas for new reports, as in your case, what is the most popular posts and so forth. So I got the idea to create another war just for the reports. This was the reporting. So I could redeploy the reports without affecting the statistics. So as you can see, I actually started with a simple filter. And I end up having 1, 2, 3, 4 different microservices. It couldn't be more effective, more productive than one filter. But now I have the benefit, I can, in running application, deploy new statistics without affecting my blog. The question is how they communicate with each other. So consistency, not an issue, because if one hit gets lost, I don't care. So what I did, just to give you an impression, I use Hazelcast here with Jcache, wrapped with Jcache. And if you're interested, what's wrong with my Jcache? And if you're interested, go to my GitHub and search for a project called Headlands. This is exactly what I'm using here. And what it is, Jcache wraps Hazelcast and exposes via REST. So it means this put here happens in a hash map, and Hazelcast replicates the data for me to this microservice. So now I could get scalability, still not issue in my blog because it's not, this is not Amazon.com, it's just a Java 8 blog. But what I'm able to do, I can implement new queries, by the way, with Java 8 lambdas is very easy, which go against Hazelcast without affecting anything else. If you look at this, it's a microservice architecture with plain Java 8 without external libraries except Hazelcast. And the first start was this route to a JPA database. So, and now I say, okay, because I have two wars, I need to replicate the data somehow, and I used Hazelcast in this example. I could equally well use Infinispan. It does not actually matter. So you got my point? So the first idea is to extend the monolith. Was not possible because of lifecycle issues with Hibernate and Spring. Then I say, okay, fine. I create another process which gathers the data. And the next issue was if another process gathers the data, and I would change the reports the whole time, I'll have to redeploy the gathering process, and it affects everything else. So then I created, okay, then I create a report process, this was exactly your idea, which replicates with the gathering data process, and now I have microservice architecture on my server. Back then, I didn't knew that this is microservice. Now I would sell it as microservice architecture. Okay? Any questions? 3 minutes? Yes. Yes.
Separate platforms, and that's radically changed the architecture. And how would the behavior monolithic?
Very good. So what you are saying is not like we have everything one war. It's more like we're buying at Amazon and shipping via DHL or whatever. Funny story. There is an old book. It's called Web Services in Practice from O'Reilly. And it does exactly this. It's about 10 years book about buying at Amazon and going against Craigslist, everything with SOAP. 10 years old book. You can just read it and apply it to microservices. Like Web Services in Practice. So book is O'Reilly book. But the funny story is, before microservices, we call this integration. How it's called? Integration something. Enterprise integration. B2B or Enterprise Application Integration. EAI. All the conferences, I was in conference in Germany, there was like EAI forum, then was renamed to SOA forum, and now I'm just waiting for the microservice forum, right? But the funny story is, by the SOA forum, at the end, there were more speakers than attendees. This was interesting, so interesting thing. But so what it means, we would have to integrate Amazon with DHL in our microservice. So I will wrap them as whatever. So we did it for years. It could be JMS if it's deliver once and only once, JCA if it's transactional, if not REST. For instance, a classic case in enterprise was if you have an insurance computation, like the C kernel which computes something, you have to integrate this. So whether it comes from the outside or inside, it's a C or COBOL or whatever, you have to integrate the stuff. And this was something like a microservice. Now I would call it microservice. Back then, we call it just, I don't know, an interface or AIE or whatever. The names are changed over and over again. What's probably interesting, I think there's common sense that ESB is not a very good idea. Enterprise Service Bus in such a cases, because it's really easy to integrate backend services if they are reasonable. Okay? So you got my point? So if in your enterprise, in your business logic, if you're a startup or not, you have still your stuff to do. And your stuff can be monolithic. And there are other endpoints which you have no influence on. So you have to call them remotely. This is what boils down to. Sorry, I interrupted you?
In your presentation, you only compared the separated business and cloud process, microservices and the monolithic.
My goal was actually to show you that if you start with a monolith and you're reasonable, you will end up having of microservices or not. Depends how lucky you are. If you have more teams, microservice. If one team say, okay, monolith is still easier. Keep it simple, stupid, simplify it the whole time, and you can survive the project. This is hopefully point of my presentation. Agreed? Very good. T-shirt, of course. Come to me. So, so any other questions? I have 4 seconds for a question. No? Then come to me. I have stickers and T-shirts. Who ask question T-shirt or ask questions after the show. So I stay here for 1 hour. Then I fly back because of Java E projects. And see you next year. And yeah, hopefully next year. Or Java 1. Okay. Thank you.